In the first part of this tutorial, I will show you how to prepare a CHEMIX ternary diagram for publication. In the second part, I will do the same, but now by using pen and paper. The last part is mainly for comparison and reference.
Click the ternary plot button. We start by inserting the title text in the upper text field. We also need to insert text close to the three corners of the diagram. Acetic acid. Water. And at last, chloroform. In our experiment, we have found 5a, b, border areas where the phases change from one phase to two phase or vice versa. We will now insert 5 normalized pairs of data based on weight percent. 5a values, representing acetic acid, and 5b values, representing water. We need to extrapolate down to the b-axis by introducing 2 additional points, to separate the one-phase region and two-phase region by spline interpolation. We can visualize that those additional points are artificial by labeling them using both text and New York, changing the symbol color from black to red. It is also possible to change the text angle. In this case from 0 to 20 degrees. To change the font color from black to fuchsia, insert a color command. To get more information about the available symbols and text commands options in CHEMIX School, use the Help button. That's the button with the question mark. In CHEMIX School, there are 2 ways to separate two-phase regions by a curve. The first way is to create a spline curve by using the raw data directly. The second way is to create a spline curve manually, or by hand. In the interpolate area of the software, click the drop-down box and select the natural cubic spline. As displayed here, a spline curve now connects the data points. We want to fill two regions by colors. To do that, simply select Fill Mode and two colors. To manually insert spline points, set of a few points by the mouse cursor, in this case 4 points. Drag the first and last spline points here seen as rectangles downward, so that the spline curve is in direct contact with the B-axis on both sides. As we did in the interpolation example, we will now fill those two regions again with color in the same manner as we did then. Select Fill Mode and a color. Insert fill point number 1 by clicking the mouse in the lower region. It is possible to move the fill point by the mouse. Be sure that the spline curve is in contact with the B-axis, or it will bleed color into other regions as demonstrated here. Select fill point number 2 and a color and insert it in the upper region. In some cases we want to label symbols by text. To do that, simply insert text after the A and B coordinates. To see the changes in the diagram, press the Calculate button. We want to put some informative text in the upper and lower region. But first we have to change data set. To find the position for our text in A and B coordinates, activate the View Coordinates checkbox by clicking it. This is a fine place to start the upper text. A equals 50, B equals 15. The lower text can be placed here. A equals 14, B equals 32. We don't need to view the coordinates anymore, so uncheck it. To remove the symbol in front of the text, we have to insert a data entry command, in this case, -s. To increase the font size, we insert a giant font, or the GF data entry command. If we in addition to the text in the diagram want to insert legend text, select Data Set 1. In the legend text field, insert your text. Select the same color as in the upper region. Select Data Set 2. Again, insert your legend text in the empty text field. Select the same color as in the lower region. To move the legend box, just grab it with the mouse pointer and move it around. We can remove all the fill and spline points by unchecking the spline and fill points checkbox. To save our work, insert a name for our experiment in the Name Experiment text field. Mark a list element by single-clicking it. Save by pressing the Before or After button. It is also possible to replace or delete already existing listings. If we are going to publish our ternary phase diagram in a scientific journal, we want the best quality possible. Press the button with the two triangles and copy a high-resolution version of the diagram to the clipboard. If we somehow want to modify or print the ternary diagram, simply paste it into a paste-enabled program, such as Paint. The corners of a ternary phase diagram represent both 0% and 100%. In the upper triangular corner, A equals 100%, and C equals 0%. In the right corner B equals 100% and A equals 0%. In the left corner C equals 100% and B equals 0%. In this example A is replaced by acetic acid. B is replaced by water. C is replaced by chloroform. As we can see in the table at the top right, we have found 5 boundary areas where the phases change from one phase to two phase or vice versa. We will now plot these data points in the phase diagram. As displayed here, the A and B axis are already marked in 25% intervals. We will now transfer the values in the data table to markings along the A axis and B axis in approximate positions. Before we can insert the data points, we have to prepare the diagram by extrapolating lines from our markings. Now it's time to insert the data points. To make the curve appear natural, make it as smooth as possible. When using the interpolation option in CHEMIX School, we have to add a couple of artificial data points to extrapolate the curve on both sides to the b-axis. If we want to label our symbols, simply add text to the data set entries. In this example, we use S1, S2, S3, S4, and S5, representing samples or solutions. We can also label our 1 and 2 phase regions. The last thing to do is to colorize both phase regions with two different patterns or colors. It's just another CHEMIX School tutorial. Thank you for watching. Don't forget to subscribe.